Hi, and welcome back to Batee.com. Today we're going to show you how to repair the 1986 through 1988 C68 electronic climate control. The problem that we're dealing with today is that when we move the temperature higher or cooler, the blend door motor doesn't move. And this means the unit is probably blowing hot air when it should be blowing cold air, or it's blowing cold air when it should be blowing hot air. Fortunately, that's an easy fix. Other problems that this repair video will solve: if we see a blank display, or if we see no yellow LEDs, or if we have no clicking of the solenoids or relays, this will also help that. Here we see the C68 HVAC repair kit sold by Batee.com. I'll leave a link in the description below this video. It contains a new set of electrolytic capacitors for both the programmer unit and for the controller unit. It includes new power resistors to drive the blend door motor. It includes a new set of bulbs for the controller unit, and it includes a supply of solder.
Recording.
Gotcha. Okay. The first component that we'll rebuild is the programmer unit. This is the unit with solenoids that control the vacuum lines, which drive the air conditioning diverter box. And we're going to disassemble this. We'll start by removing the nut from this long bolt, and we will just turn that counterclockwise with a 5/16 inch socket or a pair of needle nose pliers. We'll remove the nut, and the bolt should drop out the bottom. We'll use a 1/4 inch nut driver, and we'll remove the two screws located here and here. Then we'll turn the unit upside down, and the board drops out. We'll set the screws aside someplace safe. Here we see the circuit board for the C68 programmer module. We're going to try to work around the vacuum lines without removing them. But if you do decide to remove everything, if you do need to remove the vacuum lines in order to do a repair, make sure to mark them very carefully, or maybe take a photo of everything so that you can see exactly where each vacuum line goes. Okay, common problems with this unit are failed power resistors here or here, and sometimes we see problems with corroded solder joints on the solenoid. One of the more common problems on the programmer board are cold solder joints at the location of these power resistors. The electrolytic capacitor on this board is at least 25 years old, so we will replace it. And we'll also look for and repair cold solder joints at the connections where the solenoids join the board. So we will start by removing the electrolytic capacitor. The terminals are here and here. In this case, the board is marked with a positive terminal, so we don't need to mark it ourselves. The way we remove a component is we'll apply heat. We'll apply heat to the connection. We'll feed in some fresh solder, which also contains flux. When everything's molten, we'll use our desoldering tool or solder braid to remove the excess solder. We'll do the same thing on the next connection. Heat and vacuum away the solder. And the component drops away from the board. We will use one of the new capacitors for the replacement. We'll use a pair of needle nose pliers and try to bend the leads the same way that they're bent from the factory. Finally, we'll install the new component. The negative terminal is going to be the terminal away from the notched end of the capacitor. So this is the positive end of the terminal. This will install toward the positive mark on the board. We'll insert the new capacitor and we'll bend the leads apart slightly to make sure that it doesn't fall out while we're soldering it in place. So next we'll solder the new component in place. We'll apply heat to both the leg of the capacitor and the pad of the board. We'll feed in some fresh solder, and once everything is molten, we'll remove the heat. We'll do the same thing for the next connection. Apply heat, feed in some fresh solder, and remove the heat. We'll use our wire cutters to trim away the excess length of the leads. So next we'll move on to the power resistors. The power resistors are located here and here, and we'll remove those the same way. In this case, we do see some failed solder connections. That's probably why we're seeing the trouble that we're seeing, but we'll go ahead and replace those components just to make sure. We'll apply some heat. The resistor went ahead and dropped out, which is great. Now we'll vacuum away the excess solder. The board's actually nice and clean, so we don't need to do any extra work. If yours isn't that clean, we'll use some desoldering braid and heat from the soldering iron and a slight scrubbing action to clean up the board. We'll bend the new resistors at approximately the same location that the factory resistors were bent. And then we'll install these in place. There is not a correct polarity for these resistors. They can be installed either way. We'll hold them in place. We'll bend the leads apart slightly to hold the component in place while we solder it. We'll do the same thing for the second one. Solder the components. We'll apply heat to the junction of the pad and the lead of the resistor. We'll feed in some fresh solder, and then we'll remove the heat. Your connections should be nice and bright and shiny. If they're not, it's fine to go ahead and vacuum off the solder and try again. We include plenty of solder with the kit. Finally, when you're done, we'll use wire cutters to trim the leads of the resistors to length. The final problem area on the C68 board is at the electrical connections of the solenoids. These are going to be the pins that are connected through to the solenoids. We frequently see cold solder joints here. So we'll go ahead and clean those up. I will heat the connection, apply some fresh solder, and vacuum away the old factory solder. And then I'll heat the connection, apply some fresh solder along with the flux contained in it, and let the joint cool. I'll only do one of those at a time so that the solenoid does not fall out of place. But I will go ahead and do that for both connections on each of the 5 solenoids. While it's apart, we'll go ahead and use a wire brush to clean up the electrical connector. We want to be very gentle with this. We want to remove any tarnish that we see. Finally, we'll reassemble this unit. We'll put the cover back in place. We will reinstall the 2 1/4-inch screws that hold the board in place using a 1/4-inch nut driver. Screws are located here and under the vacuum line here. We'll install the long aluminum bolt through the hole in the block of vacuum lines. We'll go ahead and reinstall the nut, and here we see the repaired programmer module. Okay, the next step is to disassemble the controller unit. We'll use a small flat-bladed screwdriver, and we'll pry the clips on either side gently away from the unit.
Alright, we're recording.
Okay, the next step is to press slightly on the electrical connector while we use the flat-bladed screwdriver to release the catch that's holding the circuit board in place. We'll do the same thing on the other side, and the unit comes apart. We'll gently separate the faceplate from the logic board. Common problems that we see with these units are that the light bulbs fail, that this connector becomes deformed over time and needs to be reshaped or replaced. The electrolytic capacitors on the logic board are at least 26 years old and need to be replaced. Those are located here and here. And the kit that we sell contains parts to repair all of those problems. First step is to remove the old electrolytic capacitors. To do that, we'll apply some heat and some fresh solder, which contains flux. We'll remove the solder from the capacitor terminals the same way that we showed you in the previous segment. And then we'll lift the electrolytic capacitor away. We'll do the same thing for the next capacitor, located here. We'll apply heat and some fresh solder. We'll remove the old solder. Do the same thing on this terminal. We'll lift the old capacitor away. And in this case, the positive terminals of those capacitors are marked on the board. The smaller one is located here. The larger one is located here. So we'll bend the leads of the new capacitors to approximately the same width that the factory capacitors were bent, and then we will install them. The positive terminal is the terminal with the dented edge. We'll match that up to the markings on the board, install the capacitor in place, and we'll bend the leads apart slightly to keep the component in place while we're soldering it. We'll do the same thing with the larger capacitor. To install the new components, we'll apply heat to the junction of the capacitor leg and the pad on the circuit board. We'll feed in, once it's hot, we'll feed in some fresh solder. When everything melts together, we'll remove the heat, and we'll do the same thing for the other terminal. We'll solder both capacitors in place. Finally, we'll use our wire cutters to trim the capacitor legs to length. Here we see the repaired board along with the parts that we replaced. The kit includes another capacitor. It isn't present in this particular model. If we were replacing that other capacitor, it would be located in approximately this area, and you would replace it using the same techniques that we just showed you. We also frequently see some failed solder joints at the power resistor located in this location. So we're going to go ahead and rework those solder joints. One at a time, we'll remove the old factory solder using heat and some fresh solder and our solder removal tool. Once it's gone, we'll apply heat to the junction Next we will rebuild the faceplate. We'll start by removing the 3 light bulbs located here, here, and here. We're going to turn them approximately 1/8 of a turn counterclockwise and lift. One of the things that we frequently see is over time this connector warps and the connections between the faceplate and the logic board break or become intermittent. We can temporarily help that by reheating and shaping that connector. This is a last-ditch effort before we replace this connector. We're going to use a heat gun. This is looks like it's about a 250 watt heat gun. We're going to gently heat that connector set. Our goal here isn't to completely melt it. It is just to relax the plastic enough for it to go back into place. Another thing that I do is I'll use some needle nose pliers to force that connector set back together slightly. I'll wait for it to cool, and then I'll go to the next section. I'm just continually heating this. I'm trying not to heat the circuit board. I'm trying to keep the heat solely on that plastic connector. We'll squeeze it together and again let it cool a little bit. We'll do that one more time for this end. Like that. This technique fixes, I would say, 90 to 95% of the clusters that come into the shop. If yours is too far gone for that to work, then we have instructions online for replacing this connector set. Next, we'll replace the bulbs in these sockets. If they're stubborn, we may have to use some pliers to pull them out. Be careful, the bulbs are obviously glass. So we've removed the old bulb. We'll install the new bulb. It just presses into place. And we'll repeat that for the other 2 bulbs. Alright, we will reinstall the bulbs in the faceplate. We're inserting them. We're turning them at approximately 1/8 of a turn clockwise. This one by the connectors is stubborn, so we'll use some needle nose pliers to put that in place. There we see the repaired faceplate. Next, we'll install our circuit board. And we'll snap our case back in place. We'll snap our 2 clips into place, one on either end of the controller. And there we see the reassembled controller unit. Let's go ahead and hook everything up and test it. So we can see the repaired unit fired up. We see all of the illumination bulbs working properly. We'll go ahead and put it in auto mode. We will lower the temperature, and we see the blend door motor moving accordingly. It does move slowly. That's normal. We also hear solenoids tripping as we're changing the temperature. So let's go ahead and set this to full warm. And we'll see the blend door motor go to the other extreme. Next, we will change to the various modes just to make sure each button's working. It's not really negative 38 in the shop. There is no temperature sensor connected currently. And we do have the ability to turn the rear defrost relay off and on using this unit. So it looks like every button on the unit is working, and it's doing what it should as far as moving the blend door motor to match the temperature. Thank you very much for watching. This is another Batee.com repair. I'll put up a link where you can find parts and information to fix your C68 air conditioning controls. Thank you very much for watching.